Mark P. Otten back with you. All right, this is your introduction to z-scores and the normal curve. You see the formulas up here on the screen for z-scores and then the conversion to x. So x is a score that just comes from your data set. Could be anything. Let's say it's an exam score. And then that data set is going to have a mean. It's going to have a standard deviation typically, so let's carry on that exam score example. Suppose the mean is, I don't know, 80 out of 100. 80 would go in for the mean here. Suppose you get a 95. That would go in for the x. And then the standard deviation is, as we've covered in a different video, a measure of how spread out the scores are throughout the class. So standard deviation goes in, and let's say that's given in a homework problem. Then you could find z. Now what's the point of getting z? Well, it's a standard score. We're going to look at the normal curve in a minute, the bell curve, the z curve, the standard curve. That is that's what the graphical depiction of the distribution of scores throughout, let's say, a class taking an exam. So the z-score is the position on that curve where the score falls. So if the z-score is 0, it's going to be right at the mean. If your score, let's say the mean on the exam is 80 and your score is 80, then your z is going to come out to 0 because you're right at the mean. If you're above the mean, the z-score is going to be positive. And if you're below the mean, the z-score is going to be negative. If you're one standard deviation above the mean, the z-score comes out to 1. If you're let's say 2 standard deviations, hopefully you're not 2 standard deviations below the mean. That's a score that's not very good. But in that scenario, then your z-score would be -2. So that's the meaning of it. Why are we doing this? What's the reason for it? Well, you're going to see psychology research, the normal curve, z-scores comes up periodically. It just pops up and you're like, oh, I'm glad I studied that. Yeah, that's the short version. But it's also in particular useful if you're trying to take 2 different scales. Let's say we have 2 different exams and they're on one of them's 1 to 100 and the other one's 1 to 10. And you want to compare the 2 equally. Then you convert them both to z-scores and you can do that. So for example, if let's say you're given a scenario where you have a certain mean and standard deviations different than another certain mean and standard deviation, you can convert those 2 to z-scores and then compare. And the higher the z-score, whichever z-score is higher is further to the right. If it's an exam, let's say further to the right means more positive or a better score in that case. You also see the switch here. So x equals z times standard deviation plus mean. Well, that's useful if you're given, let's say, a z-score and you want to plug in that to get an x. X is just the score, the exam score, whatever is on your scale there, given in the problem. So sometimes maybe in a homework problem you're asked for a z, you're given an x. Other times you're asked for an x and you're given a z. And so this is the way of going back and forth. And you could also be given a mean, or you might be asked for the mean. You might be given x and z and a standard deviation, let's say, and you might be asked to get a mean. So the formula works either way. If you want to brush up on your algebra, so for example, to get from one to the other here, from the z formula, I multiplied both sides of the equation by the standard deviation to get rid of that division there. And that's why in the x formula, there's a z times standard deviation. So if you want to brush up on your algebra skills, just let me know. There's no shame in that. Some folks are going to be experts in algebra and most folks are not. So just let me know if you want help converting back and forth these formulas. But let's look at what the z-score looks like in a graphical depiction from the website. Okay, I say the website. This is the website that I've been using for several years now, thanks to davidmlane.com, who posts this interactive normal curve. So some of you may have learned normal curve stuff by looking up numbers in the back of a textbook. That's how I learned it. Seems kind of old school now. But this website kind of takes care of that and makes pictures, shades in different parts of the curve based on what numbers are typed in. So there's two options here at the top. Area from a value. So you would input then a z-score to get like a percentage under the curve. Or the second one is value from an area, which is the opposite. You would input a area or a percentage under the curve and then get a z-score or multiple z-scores coming out of that. So I'm going to demonstrate both briefly here. So if you keep area from a value selected, the mean is 0, standard deviation is 1 by default, and you can play with these numbers. So let's say I want to shade in the area above a z-score of 1. You type in 1 in the above column, you hit enter, or you click on recalculate, and it's going to shade in the area above a z-score of 1, and it's also going to give you a probability down there in the bottom, 0.1587, which converts to 16% of the curve that's shaded in there, or 16% of the, let's say, distribution of scores is greater than a z-score of 1. So you can type in positive values for z-scores, you can type in negatives, you can also select these other options. So I'm going to select in between, and then the default here is negative 1.96 to positive 1.96. That happens to be 95% of the curve, so 95% is shaded in here, and the area in the down below is 0.95 for 95%. But I can change that. Suppose I want to go in between a z-score of 0.3 and a z-score of 2. Just kind of making this up. But there you go. It's shaded in. You get a 35.9% or 0.359 value there. So that's the area from a value. You're typing in z-scores and you're getting an area back or a percentage under the curve. If you switch it and you go to value from an area, now you're going to be asked for an area. So just make sure that if you're working through a homework problem, you're working with what's given. So an area might be given as a percentage. So suppose we want to look at, let's say we want 60% of the curve to the right, on the right side, and 40% of the curve to the left side. Okay, so we could go area, above is selected here, so I'm going to go area 0.4. Okay, what did I get? Well, that's actually 40% of the curve above and 60% of the curve below. If I go 0.6 and recalculate, then I get 60% of the curve above and 40% of the curve below. And that's because above is selected here by default. By the way, the z-score for that is negative 0.25. This is giving you z-scores now in the bottom as a response to you typing in the percentage. So the z-score of negative 0.25 is the value that designates 60% on the right and 40% on the left. Now we could also do like a between or an outside. Let's do a between. This one, so since 60% was already selected, I'll just leave it there. 60% of the curve is in the middle and 40% of the curve is on the outside. So 60% in the middle gives you this nice shaded region in the middle there, and the z-score for that is negative 0.84 on the left, positive 0.84 on the right. The other default setting here is that you've got the mean 0 and standard deviation 1. So you can change that now, and you can change that before as well if you want the website to assist you in converting regular scores to z-scores and so on. So suppose we have an exam like I was talking about earlier. Suppose we have a mean of 80 for that exam. You could type that in, mean 80, standard deviation, let's say is 12. Recalculate. Okay, so we've still got the 60% in the middle and the 40% on the ends because the 0.6 is typed in here. But now if you look at the x-axis, you see exam scores, right, with 80 in the middle And the shaded region designates 69.9 on the left and 90.099 on the right. So it's the same curve, same area shaded in as before, but you've got these actual scores in there, exam scores in this case, instead of z-scores. And so you can convert back and forth that way as well. You can do that on the value from an area section, and you can also do that on the area from a value section. So play around with it. If you're working through some homework problems based on this curve, let me know if you get stuck. Happy to help. I also should mention standard error, though, before we're done. Oh, and before I mention standard error, there's a thing that you might be asked, like, which score is more likely on the normal curve? Well, the mean is the most likely value. Why? Because the curve is the highest in the middle. And so the majority of scores, the most scores, are closest to that middle. And the height of the curve suggests that that's the quantity, that the quantity is highest there. So which score is more likely? If you're asked that, it's whichever one is closest to the mean, generally, if your scores are distributed normally. Okay, I said I should mention standard error. If you're working with one sample, if you're just looking at like we're doing here with the normal curve, we just have a sample one collection of scores, then to convert from standard error, to convert from standard deviation to standard error, you divide the standard deviation by the square root of n, where n is your sample size, how big your sample is, how many scores are in your sample. So, like, why do we do this other than just to give you this random formula that nobody cares about? Well, there's some logic to it. First of all, if you're asked for a distribution of sample means instead of a distribution of scores, then the distribution, the standard deviation of the sample means is the standard error. Now, what does that mean? Well, like, suppose you've got a bunch of students in a class. That's a sample of scores, individual scores from students. Suppose you got a bunch of classes and you're trying to compare the classes to each other. You would get the mean of class 1, mean of class 2, mean of class 3. That would be your new distribution collection of sample means. And then you would try to decide, okay, is our class better, smarter, whatever, than the average class? You would compare classes to each other. And for that, you would need the standard error. And in that scenario, that's a pretty common scenario in psychology research. You've got a sample of, let's say, clients who are receiving therapy, filling out a survey, satisfaction, whatever, results from those therapy sessions. You're going to get a sample mean, and you're going to try to see if that sample mean is different than expected or different than other samples that have been collected in the past. So standard errors come up a lot, I promise. You're going to see in t-tests and ANOVA, you're always dividing by something. That something typically is a form of the standard error. So practically speaking, in a homework problem, you might be asked for a standard error, and then you might be asked to go back to the normal curve and plug that standard error in. The key there, on the practical side for your homework, is just to plug in the standard error in place of the standard deviation, let's say on the website, if you're working with that. So convert first, divide the standard deviation by the n, if there's an n given. Do that first, then plug the standard error into the website or into the formula that you're working with, and use it there. That's about it. That's all I want to say for now. Like I said, standard error sneaks in there, kind of like normal curve, sneaks in there in psychology research. It's useful. You're going to say, oh, I'm glad that I studied that, or at least remember something from it, hopefully, in the future when you're doing hypothesis testing and things like that.